This next video is going to go through calculating logs, so what happens if there is no equal sign, like it doesn't give you an answer and you have to punch it into your calculator and go through and solve. So if you're looking at a TI calculator, or maybe even in, let me check what the iPhone says for that. Here, I'm going to pull that up. And you are going to have the option here to punch in that log function. And you're going to see it's literally just written as, in a TI calculator, log, and in your phone, the only option for log you're going to see is log base 10. Those are the only things that calculators are going to be able to do for you. So for example, if you had like log base 3, your calculator doesn't have that. Now, what about this one? You might be like, but Mr. R, this one just says log, so that'll work for anything. Well, for log as a function, if there's nothing written in here, there actually is. It's an invisible 10. So if you just see log by itself, again like this, there is something implied here. If they don't write anything, we're assuming that there's a 10 there. And that's assumed across all math classes, all disciplines. If you just see log, it's log base 10. So you're not going to be able to compute log base 3. This doesn't work. Calculator can't do it. So that sounds pretty disheartening. Why is log even a skill then, right? If we can only use it for base of 10, how does this do anything for us? How does this help us? Well, there actually is a way around it. So again, just to recap, your calculator is only going to be able to compute log base 10 if you see the log written there. So let's see how we get around this. We have a formula, and it helps us compute. So what this is saying is if you have log with a base of some number of another number a, you take the log base 10, again implied 10 here, of a, and you divide it by the log base 10 of b. So let's say we go back to our example from up top here. We have log base 3, and let's say it's, I don't know, 81. We can't punch that into our calculator. If we punch in the log of 81, it's not going to get us anywhere close to what the right answer for this is. So how do we fix this? Well, let's do some color coding here. This might help. We are going to take our log base 10 function over our log base 10 function and put our green term on top and put our blue term on the bottom. So if we go through and do that, 81 goes on top and 3 goes on the bottom. So regardless, are you using an iPhone, you're using TI, we're going to punch that in. Log of 81 is like 1.908 over log, again, implied base 10 of 3, gets us like 0.48. And we can take those and we can divide them by each other now and see what that gets us. Well, if we don't round at all, we're going to get an exact answer of 4. So if we didn't round here and we didn't round here, the exact answer you get now is 4. I'll see if that makes sense. Log base 3 of 81 equals 4. So if we write this in exponential form, this would be 3 to the 4th equals 81. Is that a true statement? Did our formula just work? 3 to the 4th does equal 81. That works. So again, our new formula here is going to help us compute this in calculators. So we will have some time in class dedicated to, how do you find that log function? What are you punching in? But we're going to need to do that to calculate. Let's go over one more example here. If we have log base 4 of, let's say, a big number, 16384. How do we compute this? Okay, so again, we're going to put log with the implied base 10 of 16384 over log implied base 10 over 4. And let's punch those in. 16384 divided by log of 4. And we'll get an answer of exactly 7. And again, we can check our work for this. So we can do 4 to the 7th power. And if we punch that into our calculator, we'll see that that exactly equals 16384. So using this trick is the key to being able to calculate unknown exponents, or if you have something you don't know what exponent it should be, this is going to be the answer. So again, use this formula, use log base 10. We're just putting our big number on the top, and then the implied base, the small number on the bottom. And if you do that,